Derivatives of inverse function. If f of x is differentiable and invertible with its inverse denoted by f inverse, so f with a negative 1 on top is not the reciprocal of the function f, it's the inverse of the function. We denote its inverse f inverse of x, then for all x satisfying f prime of f inverse of x not equal 0, then the derivative of the inverse function is just 1 over f prime evaluated at f inverse of x. So it's really complicated. If you look at f and f inverse, it's so many f going on, you might not know like what that is. You can just simply replace f inverse by g of x. So we're talking about two functions. We know the f of x, we know that function. We don't know much about the inverse unless we compute it. So let's say we know f well. We know it's invertible. We don't know as much of the inverse function g of x. We can compute the inverse function by using this rule. So the derivative of the inverse function, so derivative of g of x, is just 1 over f prime, and you evaluate at g of x. So we will see some example of how to apply this formula. Let's take a look at this example here. F of x equals 2 over x minus 1 and g of x equal x plus 2 over x. These two functions are inverse of each other. To verify that, we can compute f of g of x. Okay, what you get, you should get x back. And that's why we call f and g inverse. But at the same time, you also need to make sure g of f of x also give you x back. Okay, in that case, those two functions are inverse of each other. It should go both ways. Now, try not to confuse and think of, okay, what if f of g of x give you 1? Are they inverse of each other? The answer is no, because the definition is it gives you x itself back. Then it's an inverse function. So try not to make this mistake. So now we know these two functions are inverse of each other. How do we take advantage of this, the derivative of the inverse function to compute derivative? Well, if you want to take the derivative of g of x, so g of x, you want to take the derivative. I mean, you can still do it using the quotient rule, but it might be a little bit complicated, and especially when we deal with more complicated expression. But if you look at f of x, okay, it's a simple, you can apply the power rule or general power rule if you treat the 2 on top as constant multiple to f of x. So we can take a look at how this is going to work. So if you take a look at f of x, so what you want to find out is what is f prime of x. Okay, so you can rewrite f of x as 2 times x minus 1 to the negative 1 power. And then you take the derivative. Then using the general power rule, you just take down the negative 1 power, so you get negative 2 times x minus 1 raised to the negative 2 power. Then you multiply by derivative of x minus 1, which is just 1. Okay, so then this is the inverse derivative of f of x. So you can rewrite as negative 2 over x minus 1 square, because in the denominator take care of the negative power. And then all you need to do is plug it into the inverse function formula right here. Okay, so it tells you the derivative of the inverse is just 1 over f prime. So we know f prime right here. But instead of f prime of x, you have to say f prime of g of x. So all you need to do is change the x to be g of x. So it'll be negative 2 divided by g of x, so it's x plus 2 over x minus 1 square. So what it's telling you is, okay, it's 1 over a fraction. What you need to do is flip the fraction, okay? So negative 2 on the top goes to the bottom. The square term will be on the top, but if you simplify the square term, x plus 2 over x minus x over x, it's just 2 over x. And then you take the square. So again, it will be 4 over x squared divided by negative 2. It will be just negative 2 over x squared. Okay, but again, you can go either way. You can apply the quotient rule if that's simpler for you, or you can apply the derivative of the inverse function. And the real application, or to make it very easy for us to find the inverse function or derivative of the inverse function, is when it comes to trigonometry functions.